From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez.
It was almost a necessity at the time because we wanted our customers to be successful, and so we didn't want them turning all of the knobs, because the last thing the industry needed at that time was a number of conclusions around, this technology isn't ready yet, you cannot make good parts with it, we need to wait a while longer. So EOS machines were more locked down for a long time, but recently we've completely turned 180 degrees away from that and have enabled customers to use third-party materials, develop their own processing parameters that only they use with their material spec. And we're moving more and more in that direction. And
that was Greg Hayes. Greg is the Senior Vice President of Applications at EOS. Greg joins the show to discuss the world of production additive manufacturing from the perspective of an equipment manufacturer. We talk about his career in research and how he joined EOS to help build their consulting group, Additive Minds. All right, Greg. Well, thanks for joining us. Why don't we just start by having you tell the audience a little bit about your background and how you got into the additive manufacturing space?
Yeah, perfect. So, like I said, Mike, thanks a lot for having me on. It's my first podcast, so I'm excited to see how this goes. But yeah, where would you want me to start? Way back at the beginning?
Yeah, I think that'd be great. Like, what's you're a materials engineer by background, and we've had a lot of materials engineers. I think maybe that's a bias of mine, being a materials engineer. But
yeah,
was it back when you were kind of in the academic space that got you interested in AM, or something else along your career path?
Yeah, exactly. So, okay. I mean, one of the things when it comes to material science is when you study material science, you tend to either lean towards the chemistry of things or lean towards the processing of materials as you go through school. And I think, with additive being developed over the past 30, 40 years or so, then it tends to be a lot of people coming through the material science tracks wind up dabbling in some form of additive manufacturing in one way or another as they go. And, for me, it was no difference. I got into engineering when I was at the University of Delaware. Really by no fault of anyone. It certainly wasn't a plan of mine, but my roommates at the time were studying mechanical engineering, and I had aspirations of playing soccer in college. My mom was a teacher, so I thought maybe I'd do something along teaching. Long story short, I wound up at the University of Delaware with really no life plan. Decided that I wasn't going to play soccer and needed a major. And so my roommates were mechanical engineers, so I became a mechanical engineer because why not? And from there, fast forward a few years, and needed to make the next step in my life. I had a few different options. One was grad school, of course. I considered going into the workforce as well, and I wound up taking a PhD position at Penn State in the material science program over there. So I actually switched from mechanical engineering to material science. And the funding that we had when I was at Penn State was for a surgical instrument development program with the NIH. And we were all focused on making surgical instruments for something called NOTES surgery, which is natural orifice endoscopic surgery. And these things were, more or less like a small Swiss Army knife on the end of a long endoscope that the doctors would utilize. And how to select the materials, develop the materials for these things, and then process the materials is what we were working on. And at the time, there was no good processing methodology. So we explored some casting techniques. We explored some 3D printing techniques at the time, and really nothing existed. So what me and a few other people did is we actually invented a special kind of 3D printing while at Penn State, where we would use lithography molds from the semiconductor industry and we would like injection fill these molds to with a slurry or a paste of a powder material. So we were making instruments in this way. They were multi-layer molds, so we called it 3D manufacturing, of course. And that was really my start getting into additive technologies and kind of, you know, exploring better ways to do things and other ways to process materials. Yeah, you know, from there, after graduating, I went and took a job at an organization called TNO in the Netherlands. It's a government-funded, well, partially government-funded, partially privately funded research organization. And when I was there, I was kind of more of a general engineer working on a number of projects, and I worked my way up through the management ranks over at TNO. And halfway through my career over there, I kind of got back into additive manufacturing. And they were working on a number of research projects, which involved either new materials, a lot of new polymer materials, a lot for the dental industry, and also new machines. So thinking of, you know, using light in special ways to make new additive machines. So I kind of started in additive manufacturing, got out of it for a little bit, and then at TNO got back into it and helped set up a number of research programs there. And after that, ended up joining EOS. So I moved from the Netherlands then back to America, to Austin, Texas, and been there for the last couple of years.
And what was the decision-making process to go to TNO? I mean, it's I'm sure you've had a lot of opportunities in the US, but having that kind of European experience is certainly valuable. What different insights or things were you looking to gain by going to the Netherlands?
So it's a little bit of a personal story. So like all major life decisions, it involved a girl at the time. And I was looking for a way to kind of live and work in Europe. Actually, I was looking for a way to live and work in Germany, where her and her family were living. I had previously done an internship in Germany, and I was trying to contact the people that I did the internship with, which was a university along with the Fraunhofer Institute. And it just wasn't, it didn't work out. They didn't have a space available in the time frame that I was looking for. And through a few different networks that I had, I found out about TNO, which I had never heard of before, but was the Netherlands kind of version of the Fraunhofer Institute. And it seemed interesting, seemed like I'd give it a shot. And so, yeah, put all my stuff in a boat and headed over and tried to make the best of it. And I was there for almost 7 years, I think. So it was a great time. I still miss it. I still have a lot of friends over there as well.
And how did you get introduced to EOS, or where did that start?
Yeah, so while I was at TNO, like I said, I got back into additive manufacturing, and we were setting up a number of research programs. And one of the things that the Netherlands in particular really tries to stress, and what we were working on, was this concept of open innovation or shared research. So bringing together different companies in a value chain that are non-competitive to pool resources and speed up R&D. So we were using government money and private money to kind of enhance R&D efforts. So we, TNO in particular, did this in the flexible electronics space rather successfully. We were trying to build this up, or did build this up as well, in the additive manufacturing space. And so part of that effort entailed reaching out and networking and collaborating with all of the major players in the world of 3D printing. And of course, EOS was known at that time, and so I ended up getting in touch with them. The original conversation was about them joining our research program in the Netherlands, and I still remember talking to Hannes Gossner and some of the higher level people inside of the CTO organization in Munich at EOS, trying to convince them that they should come and join a research program that I was building up at TNO. Little did I know at that time, years later, that we would be colleagues and talking and working together. And it was we didn't have a ton of contact with EOS, but of course I knew all the people over there, and at the research organization in the Netherlands we had an EOS machine, of course. And one of the things that I've done in my life, which has really been a constant theme, is I've always had a bit of an entrepreneurial edge to some of the activities that I like to do. And so I've started a few companies throughout the years. Some of them are spin-out technologies from organizations that I worked, for example, like TNO. And so me and a few friends, we had this idea that we always wanted to do, was to start a consulting company in additive manufacturing. And so we realized that there was a huge need to explain the benefits of additive to companies in different industries, help them navigate the kind of confusing landscape between what's possible, how can you really wrap a good cost model around what you want to build, and really tried to make these companies successful. So we had this idea to start a kind of additive manufacturing consulting group, me and a few other colleagues. And as we were building together this this kind of business plan, and it was coming together quite nicely, I have to admit, I was contacted by a headhunter who put me back in touch with some of the old people that I knew from EOS. And turns out at EOS, they were starting and maturing this concept called the Additive Minds Group, which was effectively a consulting group helping companies ramp up their additive manufacturing capabilities. And they were interested in having someone kind of start this group in North America and lead it over here. And that was a conversation that I started having with them about, how I could do this and what plans I may have with such a challenge. And it was a really kind of opportune time, because as fate may be, I had just created my own business plan of how exactly I would do this, just not under the umbrella of EOS, but on my own. So I thought, why be independent when I can have the support and the backing of a major OEM player? And so I joined forces with EOS and put myself back on a boat and moved to Texas.
And from the EOS standpoint, I mean, they had been manufacturing machines and the top player, or at least a top two player in both the metals and polymer space for a number of years. What were they seeing in terms of, and you seeing yourself in terms of the need for additional resources to help customers? Was it along kind of the buy versus outsource to a service bureau model, or what was the, like, what types of questions kept coming up that, so like, hey, like, why don't we invest some money into a consulting company or something under our own umbrella?
I mean, some of the original questions, which are still relevant today, is really just relying on identifying applications which have good promise. So, these can be things in the spare parts side of companies, can be things more on the development side in the R&D space, but there was for a long number of years a huge challenge in just application development. And we saw that when I was working in the Netherlands. It was definitely part of our business plan, thinking about creating this consulting group. And I think EOS just in parallel saw that as well. And one of the things that all 3D printer OEMs do is they all run something along the lines of what's called a benchmarking program, where they print prototype or sample parts for companies that are thinking of stepping into this space. And I think, if I understand the story correctly from the EOS standpoint, they they saw a number of these benchmarks come through, which really needed, a little bit of tweaking, and with a little bit of knowledge about the technology, change these applications from what could be a nice showpiece into, what really could be a money-making venture. By things like how do you orientate the part in a better way to print it, asking questions like, is this part of a larger assembly and we can decrease the total number of parts, save money in assembly costs down the line. How do the support structures work with this component in particular, and what does the post-processing landscape look like? All of these type of things. And at EOS, there was a number of engineers working in this benchmarking space, and I think they just started turning these benchmarking engagements, basically into small engineering projects, and that was the birth of the Additive Minds group inside of EOS. And that's also a lot of the same types of projects that we were doing in the Netherlands as well. So it was everyone was working on these type of things at the time, which I think makes sense. And still to this day, it's relevant because there's a wide range of knowledge and experience when it comes to additive out there in different industries today. And so some need more hand holding than others, but yeah, it's still a growing field and still has a lot of work that needs to be done.
So when you go back to starting the Additive Minds group, and you presumably have to build a team and start to address some of these customer problems and kind of build a business and implement your business plan. What were you looking for in terms of the people that you were kind of bringing in on your team or having joined the team, like to really get that engagement with the customer? Because you have all, like you were saying, all these issues with adoption of different levels of adoption for customers, different levels of projects. Is it part orientation? Is it some materials? Is it benchmarking? So you have all these things coming together, and certainly EOS inherently has a deep kind of bench with machine understanding, materials understanding. So how did you put all that together?
Yeah, that's right. It's an interesting problem. How we started, so the Additive Minds group existed in the EOS headquarters in Kryling, right? And so when I joined and moved to Texas, I was bringing this concept with me to a small team of engineers. I think it was around 8 people at the time that were working in North America, they were still doing more or less the benchmarking process. And when we started talking about this concept of how can we help customers further, and how can we really be a partner with customers that want to step into additive manufacturing, not just sell them a machine or material or a piece of software and say good luck. And so the maturity path and plan was kind of obvious to all of us. So we had to come up with some sort of scalable way to interact with customers that were assessing different applications, and that spawned a number of programs and thought methodologies around part selection. So looking at product portfolios, we had to engage with them in some very meaningful way in a cost calculation tool. So thinking about what goes into really a business case, and how can they make money with our technology. So there's a number of tools that we've developed then to help them further with that. And in all of the engagements with customers, we just wrapped everything into a small project that we would do with them. At the end of the project, we would assess how it went, positive results, negative results, things are looking good. Okay, let's take the next step. After a business case and a part was selected, we usually did something around quality. So nowadays we have a number of quality programs developed, so operational or production qualification, and thinking and looking into statistical process control, and really using all of the tools that are available to us from an EOS standpoint, like a lot of the monitoring technologies and things like that, wrapping them into the project. and really just taking them from step one to up and running with production. And as the group has grown bigger over the years, so we have around, I think nowadays is around 30 people, and we do a significant amount of revenue, of turnover ourselves as well, and we're pretty proud of that fact. And different things keep getting added to the table, and so one of the things that we start working on more and more is new material development. So working with third-party materials and helping customers work out the processing parameters for a unique or customized blend of a material that they're trying to use for a special application. Another thing that we work on a lot is partnerships with software companies. So how can a simulation software be incorporated into a company's plan for using additive in a production standpoint? So we do a lot of partnership work. We're more heavily now involved in funded projects than we ever were in the past. So whether it be Department of Defense or America Makes contracts, we're always looking to join into those type of research engagements. So that's been a lot of fun, and most recently we've spent a lot of time focused on educating the market, because we believe that that's truly a way that we can help the industry scale much faster than it is today. Is just making sure that a lot of the engineers out there, know that additive manufacturing exists and know how to use it. And so we've developed together with some universities and with some other groups a whole host of courses and really an education program which we are rolling out. And so we're super excited about that and proud to see it take off. And that's the latest.
And what's the target of those courses? Is it more practicing engineers or people in university coming up through the ranks?
It's really both. So what we're starting with is a series of courses which are aimed at engineers that are working now and are wondering if additive manufacturing is right for them. So it's a lot of introductory level coursework, quick dives into things like design for additive manufacturing, overviews of the technology with that we provide, also rough business case analysis for them to think about how the technology might be applicable for them. So on the one hand, we do a lot of kind of introductory trainings, and we're really trying to do this in a scalable way. So we developed this thing called the Additive Minds Academy, which has a series of online courses, which are kind of mixed reality. So some are in person, some are typical digital e-learning type course. There's videos involved and quizzes and things like that. But we can really roll that out in a scalable way. So that's kind of more spreading the word and educating the masses. That's one avenue that this Additive Minds Academy is taking. The second path is training and retraining engineers which are already using our technology. So we have a whole curriculum built up on high level user trainings for EOS systems. So everything from basic how do you use an M290 or a P396 to more advanced data preparation methodologies, moving through any process development things and things like that. So it's I don't know, is that clear?
Yeah, for sure. And I mean, I'm excited about the second one in the sense that there's so many opportunities to optimize the process, optimize the machines. In my first introduction to 3D printing was with a EOS P110 back in the day, and we were lucky it was an academic institution, so we had an open platform and could do some of the parameter development. But I think, do you see a trend with kind of, it seems like with starting that training and getting people more engaged in almost the weeds, or like really technical into the machine usage? Do you see a stronger demand for that? Like, you have to, I'm guessing you kind of, I mean, and maybe you can argue with me in terms of here's my perception of EOS in terms of the industry. Like, you guys make very high quality, repeatable machines, geared towards production, and you kind of install them in a facility, and within the kind of bounds that you give the user, they'll produce parts pretty repeatedly. And then like that probably gets like 80 to 90% of where people are in the industry right now. And then, but you have these kind of super users, or people that are more advanced and know the technology a little bit better and know the parts they're trying to make, where you could give them extra functionality even from the start, but you kind of have to lead a horse to water almost, and kind of give more and more access
No, exactly. So EOS is 30 years old. It's sometimes amazing to remember that fact, and really, we have fought tooth and nail for the past, let's say, 7 years or 10 years to prove that we are indeed an open platform. Because the truth is, 30 years ago and maybe 20 years ago, when the technology was much more immature and not as widespread as it is today, EOS was a more locked down system. And like you said, it was almost a necessity at the time, because we wanted our customers to be successful, and so we didn't want them turning all of the knobs, because the last thing the industry needed at that time was a number of conclusions around, this technology isn't ready yet. You cannot make good parts with it. We need to wait a while longer. So EOS machines were more locked down for a long time, but recently we've completely turned 180 degrees away from that, and have enabled customers to use third-party materials, develop their own processing parameters that only they use with their material spec, and we're moving more and more in that direction. And in order to do that, we need proper training and just proper guidance for our customers to let them be successful without turning every engineering project into a PhD project. And especially with a lot of the new systems that are coming on the market now, like I don't know the exact number, but the M300, for example, is currently rolling out, and this has multiple lasers, which can have a lot of variations and combinations between them in terms of laser power, spot size, things like that. And these lasers can play with each other. They can interact independently on the bed. And if you add together all of the variations that you get, I mean, it's hundreds of thousands of combinations of different knobs you can turn to make your part in the best way. And so with all of these tools that are available now, it really takes a concerted effort on training engineers, showing them what's possible, sharing with them things that we have done as EOS, but also realizing that we as EOS, we don't test all of the different combinations, and we also don't pretend to. We want to enable our customers to use the machine and kind of take it to the next level. So now we're open, maybe even too open sometimes.
The O stands for open now, right?
The O stands for open now. Yeah. It's a stigma that everyone inside of EOS is pushing back against. It's a daily battle.
Yeah. But I think at the same time, you're exactly right in the sense that a lot of customers don't want that. I mean, there's people just starting their first investment in a $1 million machine. I mean, they want it to work. And even if it's in a constrained amount of parameters, and they want to get parts out first few weeks that they're operating. And I think it takes some time to get the folks that are using the machine to up to speed and thinking about different ways. There's probably a delicate balance there.
Yeah, exactly. And if you just look at an M290 and super common material like aluminum silicon 10 mag, and as different customers will ask us, like, is your data sheet showing properties for aluminum silicon 10 mag which are lower than what other companies have shown? And if that's true, why do you claim that you can get better properties out of this material? And can you use third-party aluminums inside of your machine? And how do you go about doing that? And the answer to all of those questions, your point, is basically yes. Like, because we have to develop a standard broad brush exposure parameter set for aluminum silicon 10 mag for the generic customer, which is then not optimized in any way, shape, or form other than stability and repeatability. So you can take that and tweak things like improved surface finish, but whenever you tweak something, you usually give something up. So do you want improved surface finish, or do you want to run the system as fast as possible to reduce your build time? Do you want to use high strength aluminum materials, which are mixing in some exotic elements into the build, or do you want the lowest possible powder price for your business case? And these are all trade-offs that are really interesting discussions, and really I have confidence in the market today because I see customers starting to ask these more thought through questions about how to best use this technology for their applications. But yeah.
And I suppose, yeah, and I think you probably sit in a really unique position within the company where you're involved or at least aware of a number of different customer projects, things are what's going on, and you hear some of these overlapping either questions, problems, and as well as kind of I'm imagining the feedback from the folks designing the machine back in Germany and across the US too, of all these different conversations. You see what's coming down the road in 2-3 years, but also kind of where is the rubber meeting the road now, and bringing that back to internal conversation. So I've been down to the Austin facility once, and you guys have an amazing site there. But I'm guessing just the conversations around the office, or when people used to go to an office and mingle. But I mean, I think that insight is probably just so valuable in terms of
and I mean, I think that my job, and I think that the Additive Minds team in EOS it's one of the best jobs in additive manufacturing out there. I really truly do believe that. And I know I've tried for 4 years now to get you to join forces with me, Mike. So maybe I can twist your arm a little bit further, but it really is cool because this team of engineers, they see everything from interacting with the university, teaching new students what is this technology all about, to working with the major aerospace and automotive companies and OEMs of the world. So, the Boeings, the Fords, the GMs, the Blue Origins of the world, and seeing what problems these type of companies are facing, to working on fun projects. Like about a year ago, we did a whole project with the Discovery Channel, building an Iron Man suit for Mythbusters, and that was just really fun and something really cool to do and to see. And if you, one of the things I really enjoy doing when the office was open, and I'm missing it now, is just walking around and looking at the desks of all of the different team members, because there are parts on the desk which are built to kind of look at new procedures and new possibilities. There's There's parts kept in our secret closets for customer development things, and there's just fun parts that are always scattered around the office. So the airless footballs and the golf clubs and the bike parts and the things that the engineers that know this technology the best build for fun to make their lives and their jobs easier. So it's really cool to see.
Absolutely. And how has, the pandemic's impacted everyone, but are there any thoughts that you have and you've observed over the last few months that will continue to change or impact the 3D printing space?
Yeah, so as a company, I would say that we've seen some of our customers really struggle with the economic downturn that's currently going on, and at the same time, we've seen other customers, really blossom and tend to grow a lot. A lot of the aerospace companies that not commercial flight but more military focused are really taking off and doing some really impressive work. So as a company, we've had to pivot a little bit, just with other customers, popping to the top of our key accounts list, which has been a really interesting thing to observe. As a company ourselves, I run a pretty I don't know how to say that. No one that works on my team has a 9-to-5 job. I think that's a fair statement.
Lean is the business school.
Yeah, lean is a great word. So, and they so people on my team are constantly traveling around to different customers. They continue to do that during the even today. So only for customers that are considered what's it called, the word
essential.
Yeah, only for these essential customers, and so that continues to happen, and they still run the machines in our offices, and a lot of things we can do remote. So in terms of watching the builds and trying to set up different builds, I think one of the things that we were working on for a long time, but really got pushed to the front, was this Additive Minds Academy educational push. And so we had ideas and we're playing with augmented reality for a long time in terms of improving our machine training. So making it possible for an engineer in any company to kind of, with their own iPhone or with their own computer sitting in front of the machine, to watch an expert user use the system, and then have their device, recognize and walk them in a step-by-step way through how to use the system in a better way. So that's something we were playing with for a long time, and since COVID-19, that's really been pushed to the forefront, and something that we hope to roll out here soon over the next month.
So like if you're doing some sort of, I don't know if it's repair is the right word, or like a maintenance operation, you could call up EOS and put your iPhone up to the screen or the circuit box in the back, and they'd be able to walk you through.
Yeah, exactly. So
okay.
Yes,
Cool.
Think of think of changing the recoder inside of the system. What are all the steps required to do that? And you can you'd be able to pull up a pre-recorded video and watch someone do this in a step-by-step way, just like you could do for many things today on YouTube or something like that. But in addition to that, you could take your phone using the camera feature of your phone and point it at your system. And what this technology allows you to do is the camera will recognize, this is the recoder arm. It'll point out to you where all of the different bolts are and what the steps are that you need to do. First open the door. It can walk you through the software steps as well as where to position things to make sure the job is complete. And it can also check. Because it's using the camera to recognize the state of your machine, it can also check to make sure that you've actually done that step before moving on to the next step. So it's not virtual reality; it's augmented reality, and it really is helpful for small things like that, and allows for a better experience. But it has to be done in the right way, because we don't want to create a hokey engagement that's more trouble than it's worth. So we spend a lot of time in trying to develop these things.
Interesting. No, that's really cool. I mean, I wish I had something like that 10 years ago when I wrote a very machine. But
just the little details of it as well. Instead of recording someone with a camera as they work on the machine, we've done things like implement point of view glasses, like the HoloLens, for example. So we have our engineers wear a HoloLens so you can see what they see and see, where their hands are moving as they look and inspect the system. And then in the video, because it's augmented reality, you can highlight different things and put notes and arrows and pop outs and things like that. It's really, it really is powerful if it's done correctly.
Yeah, it sounds like it. And so as we kind of get to the end of the conversation today, I mean, presumably you don't have to be an EOS customer to engage you at Additive Minds. How do people contact you? What's a typical pathway for a project to come across your desk? We're contactable in many different ways. You can find us just on the eos.info website. I believe that there's even an additiveminds.com website, which will lead you back to the EOS website. So you can contact us that way. You can contact anyone on the team or myself directly as well. And I don't know if you're going to link anything in this. Yep, we'll throw all the links up. So
yeah, so for sure, reach out. More than 50% of our of people that we do projects with are not EOS customers, and we're really proud of that fact, because we firmly believe that people should understand what they're doing before they spend a lot of money in a capital expenditure purchase. It needs to be worthwhile for their business, and at the same time that we want them to explore the technology, we also firmly believe that there are many ways to use this across many industries. So please come try it with the Additive Minds team. We'll work with you and make it a success.
Well, Greg, thank you very much, and we'll look forward to talking to you soon.
Yeah, thanks a lot, Mike. We'll talk soon.